x, right? Linear argument divided by the slope. So this becomes 1/16 sine 2x. Here, an eighth times a half is a 16th, and it's just times 1. So we get minus 1/16 x. All right? We have an eighth times a half times the antiderivative of cosine 4x, which is, right, the antiderivative is 1/4 sine 4x, right? So we end up with an eighth times a half times a fourth. So 1/64 sine 4x. And now all we have left is this little 1/8 integral cosine cubed 2x dx. Okay, let's focus on that guy for a minute. How do I integrate cosine cubed? What do I do first? Pull out a single cosine, right? Joey, what do I do next?
Write cosine squared in terms of cosine.
Yes. So now, we've got a 1 minus sine squared 2x. All right, Kate, how are you?
Good.
Good. So, what do I do next?
Make u sine 2x.
Beautiful. So, I let my u equal sine 2x. So my du, Noah Durrani, is
1/2. No.
that's antiderivative. Let's go derivative.
Oh, it's 2 cosine.
Beautiful. I know. When you're doing both back and forth in one problem, it's really easy to get them mixed up. All right, so my du is 2 cosine 2x. So 1/2 du equals cosine 2x. All right, so let's see what we've got now. We have negative 1/8 times 1/2 integral. This is 1 minus u squared du. We're almost done. So this becomes negative 1/16, and then antiderivative of 1 is just u, plus, so I have 1/16 times a third, so 1/48 u cubed. And putting it all together, I'll put my plus c at the very, very end. So there's my integral. 1/8 x plus 1/16 2x. Of sine 2x. Oh, you know what? I had like terms I could combine. So this is just a 1/16 x. Save myself a little space. Okay. Let's see, so I got that, minus 1/64 sine 4x. Minus 1/16 u is sine 2x. Plus 1/48 sine cubed 2x plus c, and I think I can combine. Look at this. They're gone. is, right? 1/16 x minus 1/64 sine 4x plus 1/48 sine cubed 2x plus c. The original problem that we started with about an hour ago was sine squared cosine to the fourth. Yes. Ah, there you go. My hope, in all honesty, is that there are no even powers on the AP exam. That's my hope. Right? Yes.
It is, it's gonna be multiple choice.
Yes.
It's on the AP test, I'm working the paper walk.
Find those.
Question, Mrs. Price.
Yes.
Grammar chapter 7.
You know what? I have to check. I honestly couldn't answer that. I really don't know. Okay, this one's not so bad. I know it's an even power, but it's not quite as bad as the last one. Yes.
So somewhere in there you say that
Because
it
cosine
can't be on the multiple choice.
did you write down your identities? Cosine squared is 1 times 1.
I signed up for AP.
Cosine squared is 2x. Like 1 times 1 cosine. Right? And I shouldn't be learning. Oh, wait, no, that's it. Yeah, yes, each one of them is cosine. So you have to double. Yep.
What about BC?
Okay, so try this one. You can do this. I bet you can do this start to finish. I've given you kind of some step-by-step instructions. It's not near as long as the last one, honestly. I'm not lying. The last one was by far the hardest problem thing. After we get through this, we just have tangents and secants, and then we're done.
That's it?
Yes.
Yeah. Can I tell Miss Price the time?
Yeah, I'm already on my 10th.
Okay, so the problem took us 15 minutes, I could just say 15%.
Wait, the problem took you 15 minutes, you could have saved what?
15% more.
On your car insurance. That's good, I like that one. How are there 3 staplers in here?
Wait.
Okay.
Wait, didn't she pull the problem so we can know?
Depends on what we're talking about.
Multiply out the binomial. You just type it into our calculator.
Yeah, remember guys that these are based on double angle identities, so you have to actually double the angle when you reduce the power.
Yeah, I was like, what's the point of this?
you have trig functions to single powers, just to the first, you don't need to do anything else, you could just anti-differentiate, right? So if you've got something squared, you can just do a power reduction, and then you're ready to integrate.
Okay. So that's why this one is nicer.
Yes.
It's squared, not huge.
Because it was only to the fourth, whereas the last one you had a fourth and a squared, so it was like, kind of like to the sixth, almost, yeah. Should I keep the 1/4 out? I'm gonna keep the 1/4 out. All right, 2/10 minus 1/5. You can actually combine a couple little terms in there, but that's it.
But we don't have
No, not unless it's in simplified. All right, so odd power, happy, right? Odd power, pull out a singleton, convert all the rest to something else, integrate, right, U sub. Even power, you're gonna have to do power reduction, right? So even power means you're gonna have to do power reduction, yes?
Isn't it plus 1/5 sine 10x? Since the integral.
Ooh, what is the integral of cosine?
Oh, it is sine. Yeah. Okay.
Yep, yeah. Easy to get mixed up. Probably one of the most common mistakes. All right. Whoop, going back.
Doesn't cosine squared 10x, doesn't that become 1/2 1 plus sine 20x?
No, it's cosine. Cut the, and it's all based on the fact that cosine, you're right, let me extend. It's all based on the fact that cosine 2x is cosine squared minus sine squared. So if we end up with 2 cosine squared minus 1, or 1 minus 2 sine squared. If we solve for cosine, we're in terms of cosine. If we solve for sine squared, we're still in terms of cosine. So no matter what, I'm sorry, I keep getting these weird messages. So no matter what, when you are doing a power reduction, your answer will always be with cosines.
So cosine squared.
So your cosine squared, if you solve this for cosine squared, you get cosine squared equals 1/2 times 1 plus cosine 2x. If you solve it for sine squared, you get 1/2 times 1 minus cosine 2x. They don't switch. Guys, it's not an automatic function switch. It always goes to cosine when you do power reduction. Okay. Now, when you're dealing with tangents and secants, it's okay. It's not an uh-oh. It's not so bad. All right. Just remember a couple things. First of all, let's think identities. We know that tangent squared is secant squared minus 1. So secant squared is tangent squared plus 1, right? So it's pretty easy to go back and forth between tangent squared and secant squared, right? Just like sine squared and cosine squared. It's pretty easy to go back and forth. But here's the beauty. What's the derivative of tangent? secant squared. So if you have a secant squared in there, then just convert everything else to tangents. So you save a secant squared for your du, get everything else for in terms of tangent, and let u be tangent, right? That is your goal for most of these. If that doesn't work, there's a couple other options. One is, remember the derivative of secant is what? Secant tangent. So you might be able to do something where your u becomes secant, like you have a bunch of secants, and then you can pull out a secant tangent. That doesn't happen near as often, but if once in a while it comes up. The other possibility, if everything else fails, is just convert everything to sines and cosines. And then try to do it using odd even powers of sines and cosines. Okay? All right, so here we go. If you can pull out a secant squared, that's usually your best bet, right? So for this one, we're going to pull out a secant squared. So we have secant squared times secant squared times tangent cubed dx. Okay, oh, now I need space to do the next step. So, okay. All right, so now here's the thing. Secant squared is equal to tangent squared plus 1. So we're going to rewrite the secant squared, the second secant squared, as tan squared plus 1. All right, it says distribute everything, but really what I mean by that is distribute the tangents. So you end up with tan to the 5th plus tangent cubed. Once you have a secant squared and everything else is in terms of tangents, let u be tangent. In this case, it's tan 3x. All right, so Noah Christopher, how's it going? Good. What's the derivative of tangent 3x? 3 secant squared 3x. Yes, beautiful. Very good. All right, so now what we have here, if we divide by the 3, is the secant squared 3x dx becomes your du. And you just end up with a 1/3, and this is just u to the 5th plus u cubed du. So our integral is 1/5 times, or I'm sorry, 1/3. So 1/6 u to the 6th plus 1/4 u to the 4th plus c, and then you just put your tangents back in. And I'm going to go and distribute. So if 1/18 tangent to the 6th of 3x plus 1/12 tangent to the 4th of 3x plus c. How perfect is this? We have 5 minutes left and we have 1 problem left. And it's a you try. Oh,
Bryce, you're just making my day.
I know, I'm so glad.
Favorite on the thingy.
Ugh. I don't know what's going on with this. Go away.
Thank you.
Yes.
Yeah, and that's the attitude.
And now you're saying what?
No, I was just
You
saying.
can't use another sheet of paper?
No, I was saying color.
Oh, I know, yeah. People are complaining because it's the first time all year they've had to use more than one sheet. Something of this nature will be on your test. I'm not sure which type, so I have to look. It's been a while since I
As
took
long
my
as it's
test.
not too even.
Watch, it's two evens.
Probably is too even.
Now, if I remember right, it's not two evens. I actually think it was a pretty simple one.
You wanna scroll?
Give me a scroll?
Yeah.
You don't scroll.
That's what I'm doing. You convert it all. Oh, you have to convert.
Oh,
Yeah.
Yeah, that's what
Yes. Distribute first.
I distributed everything. Converted it to.
All right, for time's sake, I'm going to walk you through. All right, so split it up into two tangent squares. Tan squared 2x times tan squared 2x dx. All right, so we're going to convert one of these to secant squareds. I can never remember, is tan squared equal to secant squared plus 1 or secant squared minus 1? It's minus. Are you sure?
Check.
Okay, now we have to distribute it out. Sometimes these problems require you to kind of play with them a little bit, right? Sometimes you might want to think, well, shouldn't I just convert them both to secants, or what should I do? In this case, it actually becomes easier if you distribute it out like that. This problem then is a u sub problem. Your u is tan, your du is secant squared. This guy you have to rewrite in terms of secant squareds.
You have to make it two separate integrals.
So we're going to make it two separate integrals. So the first one we have tan squared 2x secant squared 2x minus, all right, so this becomes the integral of secant squared 2x minus 1, like that. This we can integrate. What's the integral of secant squared? It's just tangent, right? So this one requires a little u sub. So we let u equal tan. Your du is 2 secant squared 2x dx. So you get a half du is that dx. Oops, I dropped my dx here. Okay, so we end up with, this is the integral of u squared 1/2 u squared d minus the integral of secant squared 2x minus 1 2x. So this becomes 1/6 u to the third minus, we can go ahead and integrate this, tan 1/2 tan 2x plus x plus c, and our final answer, 1/6 tan cubed 2x minus 1/2 tan 2x plus x plus c. Yay! Wow. Golden. All right. Have a great evening.